So before discussing the implementation of multi-layer security, let's first have a look at the key cybersecurity trends. Microsoft has reported a 2.75 times increase in ransomware attacks compared to the previous year. However, the percentage of organizations that reach the encryption stage has decreased more than threefold over the past 2 years, which is indicating improved defenses. The cyber-enabled financial fraud is rising globally with new trends in payment fraud and misuse of legitimate services for phishing and malicious activities. Notably, the tech scam, which traffic, which surged 400% from 2021 to 2023, far outpaced the rise in malware and also phishing, highlighting the need for stronger defenses. DDoS attacks have also involved, with Microsoft mitigating around 1.25 million attacks in the second half of the year of 2024, which is a fourfold increase from last year that we've seen. The Microsoft Threat Intelligence now tracks over 1,500 unique threat groups, which includes nation-state, cybercrime, and influence operation groups. In 2024, education and research became the second most targeted sector by nation threat actors, and it's often used as a testing grounds before pursuing actual targets. So cybercrime isn't just a technical issue anymore. It's a huge economic problem. In fact, if cybercrime was a country, it would have been the third largest economy in the world, right behind like United States and China. So this highlights just how big and advanced cyber threats have become. Cyber criminals keep evolving using new technologies and also finding weaknesses faster than ever. As a cybersecurity professionals and leaders, we need to recognize that defending against cybercrime takes more than just one technology. We have to be proactive, regularly checking our security, managing all of our assets carefully, and adopting the zero trust approach. Knowing how massive the cybercrime is to help us to understand why our security efforts are so important. We need to keep adapting, innovating, and working together to protect ourselves and our economy from this growing threat. To tackle the growing threat of sophisticated cyber attacks, Microsoft introduced the Secure Future Initiative, or SFI. So under SFI, Microsoft proactively removed over 730,000 non-compliant applications and 5.75 million inactive tenants, significantly reducing potential attack surfaces. And this underscores the importance of addressing technical debt and shadow IT in today's dynamic security landscape. So the main takeaway from this is that organizations must proactively audit systems and eliminate unused and non-compliant apps and tenants, adopting zero trust principles and maintaining a thorough set inventory are essential practices, and also for strengthening the security defenses against evolving threats. Every day, the headlines about cyber threats keep coming, and they're becoming more alarming. And these headlines aren't exaggerations. They reflect a real ongoing threat landscape that's impacting organizations and governments worldwide. Cyber attacks are no longer isolated incidents. They are daily realities affecting politics, business operations, and even national security. We need to take these threats seriously and stay vigilant. Understanding the reality behind these headlines can empower us to take action, improve our defenses, and also better protect our digital lives and assets. So security in the cloud follows a shared responsibility model, as you can see here, meaning that while cloud providers like Microsoft secure the underlying infrastructure, customers must protect their own data, applications, and workloads. The level of responsibility varies depending on the type of cloud service that is being used or combination of cloud services being used. So on premises, this is where organizations manage everything. And by everything, I mean networking, storage, servers, applications, data, and security. So this provides full control, but also means full responsibility. The infrastructure as a service, the cloud provider secures the physical infrastructure, while customers are responsible for securing operating systems, applications, and also data. the platform as a service, the cloud provider secures the platform and runtime environment, but customers still must secure their applications and data. And then last, we have the software as a service. So the provider secures everything except for the user access and data security. Customers must manage identity protection, permissions, and compliance in this type of service. Now, to give you an example, which is also related to our topic today, I want to look at the Azure DDoS protection, right? And let's use this as an example of a shared responsibility. So let's start with the infrastructure level protection. Microsoft secures Azure's core infrastructure with built-in DDoS protection. So this protects essential services like Azure DNS, Microsoft 365, LinkedIn, Nextbox, and ensuring service availability across the cloud. Now, then we have the workload level protection, which is the Azure DDoS network and IP skew. So while the infrastructure protection is automatic, and customers still must protect their own applications and workloads in that case. And Azure DDoS network protection or IP protection helps defense against large-scale attacks by monitoring traffic, detecting threats, and mitigating them in real time. So this ensures that business maintain uptime and also resiliency even under DDoS attacks. An example of this is if you have, for example, an application gateway, which in that case you have some shared responsibility, the infrastructure itself is already protected by Microsoft. However, you would still need a DDoS protection service that can protect your network, your applications, and your workloads. And that's one example, and we will go also in more details how you can do it at different layers. So now let's talk about implementing Azure Network Security using a layered approach, right? So the security controls you choose and where you implement them depend on the specific workload and architecture. In this scenario, let's focus on web applications. So on the edge protection, at the outermost layer, we have the Azure front door with Web Application Firewall, which provides protection at the edge against application layer attacks, such as SQL injection and layer 7 DDoS flood attacks. So this ensures that malicious traffic is filtered before even it reaches your backend. And then we have the network protection. So next at this level, you have your public IPs, which can be protected with the Azure DDoS protection, which provides defense against layer 3 and layer 4 DDoS attacks, right? Specifically, and not layer 7 DDoS attacks. And that's why the layer 7 DDoS attacks, you need to add also WAF for that. And which brings us to the next level or next layer, the application protection. So to make sure that to have the right security, deploying Azure application gateway with WAF adds another layer of defense. This enables fine-tuned security controls tailored to your applications. And this includes, for example, rate limiting to prevent excessive requests from overwhelming your applications. Then we have also the bot protection to filter out malicious automated traffic. And new features like JS Challenge, a security feature which we've added recently that helps distinguish legitimate users from bots. So this comprehensive multi-layered security strategy helps eliminate potential security gaps in your environment by implementing security controls at multiple levels. From the edge to the network to the application, you can create a more resilient defense, ensuring stronger protection against cyber threats. And as you can see, there are different other layers. However, that really depends on your architecture, on the workloads that you have, and the layer of defense that you need. So let's start and go discuss the different types of attacks. So first one, we're going to focus on different types of DDoS attacks. So the first type is volumetric attacks. So basically, these attacks will generate a massive amount of traffic, which will saturate the bandwidth of the target, such as your web applications. So volumetric attacks are quite easy to generate. Attackers employ simple amplification techniques to generate a high quantity of traffic that can completely block access to your end system, like a website or a service. And these attacks are measured in bits or packets per second, it basically overloads the network, and then nothing else like real access can get through. So DDoS network protection can protect your system against this type of attacks. The second type of DDoS attacks we have is the protocol attacks. They're also called state exhaustion attacks. So this type of attacks consumes all the available capacity of the web application servers or the capacity of the intermediate resources like firewall, load balancers that you have. An example of that, like you have VMSS, you have application gateways, or any intermediate resources you're using for your backends. So it abuses the flows on the network layer, exploiting protocols like IP, ICMP, IPsec, and IGMP, and flows on the transport layers, exploiting flows in TCP DB protocols. The most common example is the TCP sync flood attacks. So this attack exploits the TCP handshake by sending a large amount of TCP initial connection requests, or known as sync packets, which are spoofed with the source IP address. And usually these attacks comes also from a huge amount of bots that the attacker is using. Then the victim machine then responds to each connection request and keeps waiting for the response to finalize the handshake. But of course, this response never comes. And since these requests stay open, since they're waiting for a response, and due to the usually huge amount of requests, which is like millions of requests, it can cause your system to exhaust all of the resources and become unresponsive, right? And again, this can be at the application layer, the web application that you have, or the intermediate resources that you have. Okay, now let's go to the resource attacks, or DDoS layer 7 type of attacks, which are also known as application layer attacks. So the goal of these attacks is to exhaust the resources of the target application, and it abuses flows and vulnerabilities on the application itself. So not necessarily the network or the servers the app is running on. So for example, targeting web pages and web servers handles HTTP requests. So a single HTTP request is simple for an attacker to execute, but demands a lot more from the target server to respond, because the server likely loads files, runs database queries, calls APIs, etc., and uses a lot more resources from the server side. While from the attacker, it's quite simple to run a script or have bots running a script to send a HTTP request to the target. So these types of attacks are quite challenging to identify and defend, because the traffic seems very legitimate, and can be difficult to be sure when it's malicious, because the requests they send are legitimate. There is usually almost nothing in the request that is, let's say, malicious, and that's why it's more difficult to find these type of attacks. So when you're creating your strategy for DDoS protection, it's important to know that the Azure DDoS protection provides a DDoS protection layer 3 and 4, while you can supplement with using WAF and features like bot protection, rate limiting, and also JS challenge to protect against layer 7 DDoS attacks. Okay, so now we had a look at the different types of DDoS attacks. Let's look at the application attack types. So the first one, which is DDoS attacks, we've already talked about this one. Then the next one we have is the web application attacks. So these are sophisticated attacks. They target the specific application vulnerabilities. And these can be like SQL injection, cross-site scripting, or remote file inclusions. So Azure WAF leverages the OWASP core rule set to defend against these type of threats, which provides layer of security to the new tactics of the cyber attacks. And examples of these attacks, we have SQL injection. So SQL injection, the attackers inserts a malicious SQL queries that inputs fields in to manipulate the databases. Then we have the cross-site scripting, where attackers inject malicious scripts into web pages viewed by other users. We have also OS command injection. Attackers execute arbitrary operation system commands on the server itself. Then another example is the remote file inclusion. And this is where the attackers include remote files in the web application, leading to code execution in this case. For the last one we have here is the malicious bots. So these are automated programs that scrape data that are like probing for vulnerabilities or performing credential stuffing. They can cause financial loss, competitive disadvantage, and even legal challenges. And some examples of these are, for example, the DOS bots, which are bots that perform denial of service attacks that I mentioned earlier. We have also the content scraper, which are bots that scrape contents from websites to use it elsewhere. And we have also the price scraper, which are bots that scrape pricing information from competitor websites. And you can use Azure WAF to block different types of these bots. Okay, now let's start with Azure DDoS protection. And before going into the Azure DDoS protection product itself, let's look at the state of DDoS attacks. And the information I'm using here is from the latest Microsoft Digital Defense Report 2024, which was published recently. And this is a great report. You can find it also online. It's very comprehensive. And if you want to read more about the defense report for 2024 written by Microsoft, then I definitely recommend you to have a look at it. And you can see, for example, the evolving cyber threat landscapes. You can see into DDoS attacks, social engineering, and different types of attacks, and what we are seeing today. So the state of DDoS attacks, right? So starting in mid-March 2024, we saw a sharp increase in network DDoS attacks, reaching a peak of 4,500 attacks per day by June. While the DDoS attacks have always been a persistent threat, what stands out is the shift in focus. So from traditional network layer attacks to a more stealthy and sophisticated application layer attacks. So unlike network attacks, the application layer attacks are designed to mimic legitimate traffic, as I mentioned earlier, which makes them much more harder to detect and mitigate. And these attacks, ranging from 100,000 to 1 million packets per second, usually target web applications, aiming to overwhelm the backend resources while bypassing the traditional network layer defenses. So the business impact that we are seeing from this is that the shift is an attack strategy that has real-world consequences affecting the critical services, for example, like online banking platforms, where attackers disrupt financial transactions. And we've seen also airline check-in systems causing delays and also operational challenges. So without adequate application layer protection, these services face significant availability risks, leading to potential financial and also reputational damage. So the need for robust defense, right? To counter this new evolving threat landscape, organizations must implement layered DDoS protection, as I mentioned earlier in the layered approach. And then there is the application layer defense, which is, you can use WAF to block sophisticated attack patterns. Then you have the network layer DDoS protection, which is to absorb volumetric and also protocol attacks. And of course, continuous traffic monitoring, right? So you need to continually and monitor these stealthy attacks in real time so you can mitigate them. So as attackers adapt their strategies, business must stay ahead by enhancing their security posture and ensuring resiliency, always available digital services. Okay, so let's start with Azure DDoS protection, and let's go into some of the several key features that this product has, right? So the Azure Global Network, by leveraging the Microsoft expansive global network, Azure DDoS protection can absorb and mitigate large-scale attacks. And today, it's almost more than 100 terabits per second, which is to ensure customers' applications remain available and also performant. Then we have the adaptive tuning. This feature learns your application's normal traffic patterns over time, allowing it to distinguish between legitimate traffic spikes and actual threats, thereby reducing false positives. So attack analytics and metrics during and after attack, Azure DDoS protection provides insights into the attack vectors, traffic volume, and also mitigation actions, helping you understand and also respond to these threats effectively. Then we have the integration with Microsoft Defender for Cloud and also Microsoft Sentinel. So we have the integration with these services, which enables centralized monitoring and also management of security events, facilitating efficient detection, investigation, and also response to these threats across your Azure environment. So the last two, we have the rapid response team. So in an event of an active attack, the DRR team is available to assist with attack investigation and also post-attack analysis, providing expert guidance to help mitigate this impact and also strengthen the defense against future threats. And then we have the SLA guarantee and also cost protection specifically for the network SKU. So Azure DDoS protection offers 99.99% SLA, ensuring high reliability. Additionally, it provides also cost protection by offering resource credits for scaling out that happens during these attacks or documented attacks. And these help to manage unexpected expenses that you may have associated like with mitigating large scale DDoS incidents. And an example is like if you have an application gateway and it scales out during an attack, which is documented, then you can get the resource credits back for that attack. Okay, now I spoke about two different SKUs for Azure DDoS protection. Let's compare these two different SKUs, and I want to highlight the main difference for you to understand. So both SKUs offer the essential DDoS mitigation features, right? In terms of mitigation features, they are the same. They have both adaptive tuning, analytics metrics, the integration, and also Azure Global Network from Microsoft. But they differ in certain aspects, right? So the key differences is the cost protection. So only network protection includes cost protection, which provides the resource credit for scale out during documented attacks. Then we have the rapid response team support, which is the access to the rapid response team during active attacks, where IP protection does not have it. And then we have the Web Application Firewall WAF discount. So network protection provides discounts on WAF services, which is not available on the IP protection SKU. When it comes to the pricing structure, the network protection is priced at approximately $3,000 per month, which is covering up to 100 public IP addresses. And there is an additional charge for extra IPs over this 100 threshold. For the IP protection, it costs around $199 per protected public IP address per month. And it's more suitable for environments with fewer IPs, right? So choosing the right SKU, right? The network protection is ideal more for, let's say, larger deployments with a lot of public IPs. And usually it's more than, let's say, like 15 public IPs or 10 public IPs. And it also offers more comprehensive features and cost benefits once you go over this specific number of IPs. For the IP protection, it's more suitable for, let's say, smaller organizations that have a limited number of public IPs, and it provides essential DDoS mitigation at a lower entry cost. Okay, so that's for Azure DDoS protection. Now let's go and view the web application firewall. So WAF provides advanced protection for web applications against a wide range of threats. It's available right now in two different deployment models. So the first one is Global WAF, which is WAF with Azure Front Door. It is integrated with Azure Front Door, which is a cloud-native content delivery network, CDN. It provides global application acceleration and security at scale, and stops attacks at the network edge with hundreds of edge locations worldwide, so mitigating threats closer to the source. The second model, which is regional WAF, and that's WAF on the application gateway. It's integrated with the application gateway, which is a scalable regional load balancer, It protects web applications running inside virtual networks, and it supports traffic management for both internal and external applications across 60 Azure regions. So the threats mitigated by Azure WAF are, for example, as I mentioned earlier, SQL injection attacks, cross-site scripting, command injection. You have also HTTP request smuggling, HTTP response splitting, also HTTP protocol violation and anomalies, which is like, for example, missing user agent header or some accept headers. You have also bots, crawlers, and scanners that I mentioned earlier, and then also common application misconfigurations. So Azure WAF is a critical security layer. It protects you from malicious traffic. And let's have a look at the key features that we have for Azure WAF. So the Azure WAF ensures security at both the network and regional levels. So provides a comprehensive protection. You have the Microsoft managed rules, which defends against OWASP top 10 threats, CVEs, bots, and also DDoS attacks using also Microsoft Threat Intelligence. And then we have the Azure WAF at front door, which combines application acceleration, caching, and security at network edge. And for WAF at application gateway, it protects both public-facing and private applications within Azure regions. And you have also the customizable security controls, right? So you can fine-tune the WAF to your applications. You have geofiltering, which restricts access based on geographic location. So you can block specific, let's say, countries or locations that you need, or set a specific rate limit for them. Then you have also IP restrictions, so block or allow specific IPs. HTTP parameter filtering, so prevent attacks by filtering some request parameters. Or conditional rate limiting, right? So manage traffic flow and prevent also abuse of your applications. And then you have also the security insights, of course, and compliance. And we wrote a blog post recently about this if you want to check about how to do monitoring and logging metric for WAF. So you have the monitoring and logging, which gives you visibility in security events and also, for example, like traffic patterns. Then you have the Sentinel or Microsoft Sentinel integration to detect and respond to threats in real time. And of course, MDC, right? So Microsoft Defender for Cloud integration, which ensures compliance with governance policy that you have. So with this capabilities, Azure WAF offers powerful adaptive protection for modern applications and also APIs. Okay, so with this, we have covered the threat landscape, the layered security approach for network security, and also the key aspects of Azure DDoS protection and also Azure WAF. So next, let's show you how you can configure and view this directly on the portal. And my colleague Andrew will walk us through how to do it. So over to you, Andrew.
Thanks, Saleem. For that, let me share my screen. Please let me know if you're able to see my screen and if I'm also audible enough.
Yes, we can. Thank
Yes.
you, Andrew.
Perfect. Thank you very much. So in this section, we're going to go through what we've been talking about, implementing DDoS and WAF for multi-layer protection for security. So these two solutions are complementary to each other. Saleem has mentioned with Azure DDoS protection, we're able to protect ourselves against DDoS attacks, volumetric DDoS attacks. While with Azure WAF, we're able to protect ourselves at the layer 7 against common web attacks, as well as also layer 7 DDoS attacks. So we're going to go through how these two can work together. You can see here on my screen, I have an application gateway with a application gateway WAF policy. Behind this, I have a simple web application, which I am protecting with this web application firewall. On top of that, we also have Azure DDoS protection. And this has been implemented on the public IP address of this application gateway. So if we go to the public IP address of the application gateway. Under overview, you'll see here there are several tabs, and under getting started, we have associating IP, configure, and then also we have protect. So if I click here under protect, you'll see the status of the protection of our public IP address. So currently, the protection status should change in a few, and we'll see that it is enabled. So what to look out for here, we have network, we have IP, and we have disable. So network, and we can see the description, it inherits DDoS protection from a virtual network. This is for the network protection. And so for this one, we need to create a network Azure DDoS protection plan. So in terms of how the Azure DDoS protection plan looks like, it's pretty simple and straightforward to set up. Once it has been set up and running, we're able to protect our ARM-based public IP addresses. And you can see here under settings, under protected resources, we have our VNet, we have our firewall, we have our application gateway, of which this is now its public IP address. Also able to protect other resources such as bastions, load balancers, NICs, virtual machine skill sets, as well as virtual network gateways. So with that overview, we can see that our IP address, public IP address, is protected. And also in relation to that, since this is now on the network protection, also able to protect it with the per IP SKU. And to do that is now to toggle to this second option to specifically protect this IP address. So as was also mentioned, when it comes to the per IP protection, this is usually geared towards where you have maybe less than 15 public IP addresses. And of course, also in terms of cost efficiency, if you do have less than those 15 public IP addresses, you'd be able to use the per IP DDoS protection SKU. So to set up Azure DDoS protection, it's pretty straightforward. And with that, what it means that our application is now protected against DDoS attacks at layer 3 to layer 4. So what happens when it comes to logging and also monitoring and seeing what is happening when it comes to Azure DDoS protection? So with that, we need to enable our diagnostic settings. So I'll quickly go here next. So you're able to monitor through logs, and you also have measures within the metrics where you're able to see the mitigation thresholds. So as was mentioned earlier, for Azure DDoS protection, we do have the automatic tuning, which is able to see the baseline traffic going towards your application, and it's able from that to automatically tune and set up what we call these mitigation thresholds within the policy. So as an example here, you can see I'd already selected 3 of them, and they are based on the inbound packets to trigger DDoS mitigation. So we have the inbound SYN packets, we have the inbound TCP packets, and also have the inbound UDP packets. So from here, you're able to see the thresholds that has been set specifically for this public IP address in our application gateway. So as an example, we can see for our inbound TCP packets to trigger DDoS mitigation, this threshold is set at 100,000 packets per second. So if indeed there's an attack that is based on volumetric attack based on TCP, and it goes above this threshold, our DDoS mitigation will kick in. And the same applies as well for the SYN packets and for the UDP packets. So this is where you're able to see these set thresholds, and also to mention these are unique for every public IP address for every application. So even within the network, Azure DDoS network protection plan, if you do have multiple public IP addresses, these thresholds are going to be unique for each. And then also something else to note, how you can monitor if you are under a DDoS attack is to use this metric called under DDoS attack or not. And this metric shows us when a DDoS attack occurs. So this value is based on 2 values, a 0 or a 1. 0 indicating there's no DDoS attack. You can see here, this was an attack, a simulation that had been done earlier, and you can see that the value is 1. So this, in addition to other metrics that we have that also look at the number of packets that are going towards our application, we also have metrics that shows in terms of the DDoS packets that were dropped due to the DDoS attack. You're able to efficiently monitor your Azure DDoS protection and be able to see the mitigations when they do start. So in addition to the metrics, we also have Azure DDoS protection logs, and these are enabled within the diagnostic settings of your protected resource. So what happens when a DDoS attack occurs? That is when we are able to see these various logs. So to begin off, we have what we call the DDoS protection notification. So these are going to show us whenever a DDoS mitigation began and when it stopped. We also have the DDoS, the next DDoS mitigation flow logs, and this give us more specific details in terms of the traffic. They also are able to tell us what is happening in terms of the packets that are flowing. And then finally, we also have the DDoS mitigation reports. So this gives us a detailed report in terms of what happened when the DDoS mitigations were occurring. So for example, if I open this first one here, we can be able to see the attack vector, and we can see our attack vector was a TCP SYN flood attack. We're also able to see the total number of packets, the protocols, as well as the region, as well as the top ASNs, from where this attack occurs. So with these three reports, you're able to get more details. And also to note, you can be able to integrate these logs for automation with SIEM and be able to get visual representation of the logs from DDoS. So moving on, I'll next look at Azure Web Application Firewall. So this is the WAF policy. This is the Web Application Firewall policy that is running within our application gateway. So with this now, we are able now to protect ourselves at the layer 7 against web attacks that come in. So as an overview, you can see we are in prevention mode. So there are two modes, detection and prevention. So this means you are actively blocking any attacks that might occur. So when it comes to Azure Web Application Firewall, what we need to first take a look at, we'll start with the policy settings. So within these policy settings, you can be able to enforce request body inspections. You can also be able to enforce the limits in terms of the maximum request body. In terms of the request body, the maximum limit that you want for it to be inspected, as well as enforce the file upload limits. We also have the managed rules, and these managed rules come preset within the Web Application Firewall policy. So we have two types of managed rules. We have the bot manager rule, and we have the Microsoft default rule set. So in these managed rules, I'm actually using the latest rule sets. So what this gives us is the ability to protect ourselves against malicious bots with this bot manager rule set. You can see we have various categories of rule sets ranging from good bots, ranging from content fetchers, feed fetchers. And with this, we are also able to block also unknown bots and bots that have not been categorized. Within our default rule set, this is where we have our rules that protect us against web attacks. So this can be your SQL injections, remote file inclusions, path traversals, and so on and so forth. So these rules, like I mentioned, they are managed, meaning that they are updated by Microsoft. And for you as the user of the Web Application Firewall, you are assured that you are effectively protected. You are able to change the action of the specific rules. For example, if I select one rule here, I'm able to set an action to either allow, anomaly score, log, block, as well as JavaScript challenge, which we'll also take a look at in a short while. So in addition to this protection that we get, you have the ability to customize and to add rules. And of course, this will vary based on the application that you're protecting, based on your environment. And what this does is that gives you the granularity for you to also add rules based on the matches that are being seen. So as an example, you can see here we have several rules that have been enabled under custom rules of interest to us, and also aligning to protecting ourselves against DDoS attacks. We're able to configure rate limiting rules. So you can see here, the first one, this is a rate limit rule. So with this, we are able to rate limit or to control the number of requests that are coming into our application from a specific public IP address or from a specific geographical location. So like with any other custom rules, they do have priorities. I need to set it as a rule type to rate limit as opposed to match, set the rate limit duration, as well as set the rate limit threshold. So as an example here, you can see our duration is 5 minutes, our threshold is 3. Also, something to note is you're able to group by either client address, geolocation, or by none. So when you group by client address, you're basically rate limiting by the IP address, and the mitigation will apply independently to every unique source IP address. When it comes to geolocation, you're rate limiting based on a geo match on the client IP address. So traffic from the same geography is going to be grouped together. For none, it means that it's going to be rate limited at the global level. So it's going to apply to all traffic coming into your application. So with this, we're also able to match by type, match type. So we're able to match by string, by geolocation, by IP address, and then you're able to give it an action of either to allow, to deny, as well as in some deny, as well as to log this particular traffic. So this, you're able to control the rate at which requests are going to your application. Also of interest to us, we are able to configure a custom rule based on JavaScript challenge. So JavaScript challenge, you are able to distinguish between legitimate users as well as bots. So this was actually launched as a feature last year. With it, you are able to also mitigate against bot attacks, especially also, as you know, a large majority or a big percentage of bots could also be malicious. So you can see here in terms of my custom rule for JS challenge, how it has been configured. We're able to configure it as a rule type of match. We've configured it on a string. And in our example for this web application, we are looking for a match value of /FTP. And we'll see this, how it works in a short while. So with this, we are also able to effectively mitigate against bot attacks. So going back to our application, I'm just quickly going to run a quick test just for us to demonstrate some of the features that we have configured, and more so when it comes to the custom rule. So the first one we're going to test, this is for rate limiting. So like you saw in our rate limiting rule, we want to rate limit the number of requests, and we have actually selected login as one of the match conditions. So I'm just going to also go to my developer tool so we can see if indeed we get a block. So I'm now attempting to actually log in, and you can see I've hit it quite a number of times, and we do get a 4.3 forbidden. So our WAF policy, our custom rule rate limiting is working effectively. Also from this web application, we can also be able to test our JavaScript challenge, which we had configured within our custom rule. So if I do click on this particular link, and this contains a match or string we had configured, we'll see this JavaScript challenge running momentarily, checking if you are indeed a legitimate user before it allows us to go through. And if I go and check within my developer tools, I'll just go to the response headers. We'll see that a JavaScript challenge cookie has been added. So this, the JavaScript challenge has passed and it has determined that you're a legitimate user. And also to mention, if I go back to my application gateway WAF, we are able to set this cookie lifetime expiration within the policy settings themselves. So in our case, we've been able to set this to a duration of 5 minutes. So after 5 minutes, we will be challenged again. So having taken a look at an overview of WAF, what protections we are able to get. We are also, like we saw within DDoS, we have the logging and the metric. How are we able to see the logs? Are we able to see the traffic, and how are we able to use them? So with that, I'm going to go to some sample logs. Again, we do need to set our diagnosis settings. This can be within the Azure front door, as well as the application gateway, and ensure that our WAF logs are being sent. It could be to a workspace, it could be also to a SIM. So as an example here, I'd already set up this particular query to check our JavaScript challenge that we had run. So as we can see, I'd also run this a bit earlier, and we can see examples of challenges that were issued as well as passed. So we're also able to monitor any traffic that's hitting our JavaScript challenge custom rules, and indeed any traffic, if you do configure custom rules, you're also able to monitor it. And the same applies to our rate limiting, and we should be able to see actually the logs that have recently come in when we did that rate limiting. So with that, you are able, of course, also to ensure that you have visibility into what is going on within your WAF. Also to mention, we do have WAF metrics, and in this case, within our application gateway, we are able to monitor and also able to have visibility into in terms of the matches that you are getting. So here you can see a couple of metrics that are already pre-selected. We're able to see the number of hits for our custom rules. We're also able to see the number of matches for our WAF managed rules, as well as for JavaScript challenge, and also have metrics that we're able to monitor for our bot manager rules. So this you're also able to indeed see in terms of traffic, in terms of security. What exactly is happening in my WAF? Do I need to adjust any custom rule? Do I need to check any particular rule that is getting quite a large number of hits? And in addition to these metrics, we are able to create alerts. So with alerts, this will be able to notify us proactively that indeed there has been a particular match that is of interest for us, and we can do further investigations. So to create alert is pretty simple, pretty straightforward. We'll click on new alert rule. In my case, I'd already opened a new create an alert rule page. And we can see here in terms of the signal, when it comes to Azure WAF, we are able to select based on a number of criteria that we want to monitor. So in my case, I'd selected on WAF custom rule matches. I want to create an alert based on, for example, if I'm seeing JavaScript requests that are too high, if I'm seeing rate limiting, which could be an indicator, of course, that we are under an attack. And I can go quickly and be able to do mitigation measures, as well as add automation to it in order for us to be able to stop, to mitigate this attack. So to create an alert is pretty simple. You'll see the signal name, is already pre-selected. We have here in terms of the aggregation type, we have the value, which you can select either greater than, equal to. We also have the units, and then we also have our threshold. So within our threshold, this is where we set what limit do we want for this alert to be triggered, if it goes up or if it goes beyond our threshold. So in our case, we've set this as an example to 30. And also when it comes to this, it's also important to look at the historical trends so that you don't set your threshold too high or to set it too low, in which case, of course, it would not trigger. So you can see in the preview window, we are actually able to see some historical data in terms of the specific alert that we want to work on, and we're able to set our threshold accordingly. Now, when it comes to the dimensions, like I mentioned, we want to set this alert to be for our particular custom rule to see, for example, our rate limiting, is it hitting our threshold, and what can I do to mitigate this or to quickly act upon it. So you're able to select the rule name, you'll select your operator, and then here you can see we have the ability to select the custom rule. After that, you'll be able to evaluate in terms of the timelines, how often does it check, and what is the look back period, how far is it going to go back. So with this, you are also able to get proactively notified either through email, through SMS. You can also add it, for example, if you have flows that automatically check this. For example, if you have a help desk, they can easily get notified and begin looking into this. So finally, last but not least, having taken a look at DDoS and at WAF, what we're going to look at is also a bit of automation. We do have a solution called Azure DDoS Protection Solution for Sentinel. And what this does is that it gives us the ability to easily ingest DDoS protection logs into Microsoft Sentinel. And with this, you're able to view, to analyze this data within your workbooks. You're also able to query to create custom alerts. And in addition to that, you're also able to integrate it into WAF playbooks. So what that gives you is the ability to actually automate and also to stop end-to-end when you're using Azure DDoS and Azure WAF together. So for example, if there's an Azure DDoS attack, those IP addresses are going to be identified. We do have analytic rules within this solution. For example, all of them, it checks for the % threshold. So if this certain threshold is met, an incident will be created. And from that incident, using the playbook, Azure WAF playbook, we're actually able to create a custom rule within Azure WAF to block that particular IP address. So what this does is that, for example, if there is a multi-vector attack, for example, they had started the DDoS attack and they wanted now to move laterally and to access our application, they are going to also to be blocked at the WAF level. So this automation comes in very extremely useful and also brings in efficiency where we want to automate where we have DDoS attacks as well as stop further attacks using Azure Web Application Firewall. So with that, I am going to stop there. We've been able to see how you can use these two solutions together to really have a multi-layered security and be able to efficiently protect your Azure workloads and applications. That I'll hand it over to Jacqueline.
Thank you so much, Andrew. We only have one question remaining in the queue. The team's been great and very quick with their responses. How can we automate blocking of abusive IPs in WAF? They've also asked for documentation, but perhaps our team behind the scenes can help provide some links there.
Okay.
Yeah, you want to take this
Saleem?
one, Andrew? So,
yeah.
so
Go ahead.
yeah, just to give so there's a few ways to do it. Andrew showed a way to do it using the Sentinel integration that we have, and that example, what we do, we add the source IPs we find from Azure DDoS protection that we know are abusive or they are initiating different types of attacks, and you can automate it so that they're blocked automatically on your WAF policies, either on Azure Front Door or Application Gateway, right? However, there is, you can also enable the bot protection. So bot protection is also updated by the threat intelligence team that we have at Microsoft. So it's always updated, and a lot of malicious IPs are also added there. So just having that bot protection rule set enabled, you can block a lot of known malicious IPs. And then, of course, you can also do it yourself by using custom rule, by just totally blocking the source IP, or if you can just set a rate limit. If, for example, you're suspicious of the attacks that are coming from this IP, and you want to protect against like layer 7 DDoS attacks, right? So there's a few ways to do it, and we have bot protection, we have the Sentinel solution, and a few ways to automate blocking of malicious or abusive IPs in WAF. And I'll provide also documentation here in the chat.
That's great. Thank you so much to both of you. So if we have no other questions, I will go ahead and wrap us up. Thank you to Saleem and Andrew for being our guests and for sharing such great information with our community. Also, thank you to the Q&A team who helped us with answering questions and providing resourceful information behind the scenes. To all the listeners still on the line, if you're someone who wishes to aid in the protection of the world from cyber threats and desires to have a say in shaping our strategies, blueprints, and recommendations, then we invite you to become part of our security community. Together, we can make a global impact. So join us at aka.ms/securitycommunity. This is also where you'll be notified about upcoming webinars, events, and other announcements. For those of you who may have additional questions on the topic we just covered or other product-related questions, please raise them on our Microsoft Tech Community discussion space at aka.ms/anscommunity. Thank you all for being part of our community and for joining us on these webinars. We hope to see you next time. Goodbye.